We'll be looking at Module 4, Lesson 12. Today we're going to be using tables and, as we worked with in our last lesson, annotations to build multiplication and division expressions for real-world situations. So we've been working with a lot of expressions like 2 plus x or m minus 9. Today we're moving on from that, and we'll be looking at things that look more like this, maybe 12 times a, 12a, or maybe y divided by 15. So we'll be working more with multiplication and division expressions for real-world situations today. So it says in our daily lesson problem that we're starting with that a farmer's market sells these bags of apples, and in every bag there are 3 apples. So in one bag there are 3 apples. In 2 bags there would obviously be 6 apples. In 3 bags we could say that there are 9 apples. In 4 bags, we could say 12. Let's think about how we're getting these. Well, if I told you there were 4 bags, right? There are 3 apples in each bag. You'd think to yourself, well, that means that there are 4 times 3. I just take the number of bags times 3 to figure out what my answer is. So let's keep annotating backwards now and see how we did the rest of these. How did I do this one? I did 3 times 3. To figure that one out, or I did the number of bags here, 2 times 3, or 1 times 3. So that means if we know B, number of apples, I just take B times 3. So 3B, remember that means 3 times B. That will tell me the number of apples. So let's look at this next one. So it says, if the market had 25 bags of apples to sell, how many apples is that in all? First of all, that question mark is unnecessary. You can cross that off. So let's take our expression 3b, but now we're going to use 25. Instead of b, we say b is 25. Okay. Well, what is 3 times 25? 3 times 25 is 75. So we can write a sentence. We can say there would be 75 apples in all. Great. So let's say a truck arrives that has 300 apples. So it's over on this side now. Let's make this a little simpler. Let's say I did this. Let's say we had 30 apples. How many bags of apples would that be if there were 30 apples? Well, there's 3 in each bag, right? So that must mean that there's 10 apples. So if I'm trying to go back this way, right, I'm going to take 30 and divide it by 3. And my annotations look the same going down, right? If I take the number of apples, in this case it would be 6, divided by 3, that tells me that there's 2 bags. Or here I would take 9 divided by 3, that would tell me there are 3 bags. Or here if I took 12 divided by 3, that would give me 4 bags. Or think about it this way, right? If I take 3b, right, 3 times b divided by 3, remember that would also equal b. That still proves that we're true. So here, if I want to figure this out, I'm taking the number of apples a, and I'm dividing it by 3. And here a, the amount of apples, is 300. So 300 instead of a, divided by 3, so it would mean there are 100 bags. The clerks, which are the people who check out the groceries, the clerks would need 100 bags for those 300 apples. So in other words, if a truck arrived that had some number a more apples on it, we know that that's a divided by 3. But think back to our old lesson. There's a better way to write this expression. The better way to write it would be like this, a divided by 3. So there's the better expression I want to use. So my main question is, how is part B different from part C? Well, in part B, we're multiplying in our expression, and in part C, we're dividing. So we know different amounts. We know the apples for 1, for B. Now we know the apples for C. And the bags for B. So in B, we used multiplication compared to in C where we used division. In C, we used division. So that's the difference. If we know this multiplication expression, just kind of like our addition situations, right? If I know I can do 3 times B to get A, I know I can also do A divided by 3 to get B. Let's look at another situation. All right, so we're going to skip past this one right here. We're going to skip past that one. I want you to go to the daily lesson continued, where it says the fare for a subway bus or local bus ride is $2.50. So this is the one I want you to look at. It's on page 4. So this is the one I want you to look at today. All right, it says the fare for a subway for a local bus ride is $2.50. So without getting help from me, I want you to see if you can try this one on your own. So pause the video if you can, and just try to complete this table. Come back in about 1 or 2 minutes to see how you did. So give that a shot. Okay, so let's see if we can figure out some of these values, right? So if I have one ride costs me $2.50, right? I know that because I do 1 times 250. For my next one, it would be 2 times 250, and that would be an even $5. So again, that would be 2 times 250. For the next one, I do 3 times 250. And if you can follow the pattern, great, but otherwise look over here. I can do 250 times 3. 3 times 0 is 0. 3 times 5 is 15. 3 times 2 is 6. Add 1 is 7. So $7.50. So I'm taking the number of rides and multiplying it by 250. Let's try it for this one. If we have 4, I can tell you right now, that's going to be $10. For 5, it would then be $12.50. And then for 10, let's check and see with our math on that one again. So I'm thinking $2.50. I'm taking it times 10. Remember, anytime you multiply something by 10, it moves a decimal 1 to the right. So this equals 25.0, or just 25. So I have $25 here. There's my answers so far. So every time I'm taking the rides times 250. So let's look at the last one, R. So in order to figure this out, I'm going to take $2.50. I'm going to multiply it by R. Remember, that's what that means. 250R means 250 times the variable R, which stands for the number of rides. So here, if I want to figure this one out, I'm just going to take $2.50. For 30 rides, I'm just going to multiply it by 30. It's each ride. The word each helps me figure that out. First, I need a placeholder 0 for 30, right? Then 3 times 0 is 0. 3 times 5 is 15. Same thing. 3 times 2 is 6. Add 1. This would be 2 decimals up here, 2 decimals down here. $75 for 30. Also, you could think like ratios, right? Times 3 to get there, so we do times 3 to get there. That's another way you could have thought of it too. So if we let R represent the number of rides, what expression can we write? We can write 2.50R. 2.50R. Use the expression to find out how much money 60 rides would cost. Well, let's see. I'm going to take my expression, 250R. But if it's 60 rides, and right now I would encourage you to pause the video and try to figure these out on your own if you can. Really not too difficult to do. You can always look back at a couple examples. But now instead of R, I'm going to use 60 because we say that there's 60 rides. So I'm going to do 60 times $2.50. So I might do that work off to the side to figure it out. First of all, I've got this 0, and that's no good's going to come from that, so I'm going to put a placeholder. 6 times 0 will give me 0. 6 times 5 gives me 30. 6 times 2 gives me 12. Add 3 gives me 15. Got it, but now it's not 15,000. I've got 2 decimal places in my problem, so I need to move it over 2 places in my answer. So this would be $150. So 60 rides costs $150. So that's a pretty expensive bus in my opinion. All right, last one. So it says if a commuter spends $175 on the bus, how much how many trips did he take? Okay, well, this time we know the money, right? So I got to take that. And remember, each ride is $2.50. So I'm dividing this time. But I don't like having that divisor there, so I'm going to multiply by 100 and make an equivalent problem. So I'm going to have a new problem now. Now it's 17,500, so 17,500 divided by 250. Now here's the thing, I didn't need to do that much work. Instead, I really only need to move this decimal one time. I'm actually just going to multiply by 10. Now that changed my problem a little bit. 1,750 divided by actually 25. So I'm doing 1,750 divided by 25. Those decimals, any zero past the decimal doesn't mean anything. So now I can get this worked out. So first 25 times 175. Well, first I could try 17. Doesn't work out. Doesn't fit in at all. Or 1. But it does fit into 175. And I'm pretty sure it fits 7 times. So this would give me exactly 175 when I multiply. Here we go. Life is good. It works out evenly. The only thing I have to make sure I do is say 25 fits in 0 times. There we go. So the answer is 70. So how many trips did the commuter take? The commuter took 70 rides. Took 70 rides. Nice. Okay. So that looks pretty good. Now we got to think, how is part D different than part C? So again, one last time, I'd encourage you to pause the video and see if you can answer this one. How was our work for this one different from that one? All right, so here's what I'm thinking. In part D, we knew how much money was spent. How much was spent, so we divided. In part C, what did we know? We knew how many rides. We knew the number of rides. So we multiplied. So we created two expressions. Remember, our goal for today was to use tables and annotations to build multiplication and division expressions. So when we did that, we created two today. We created $2.50 times R, and that told us the cost. But we also took another one. We divided, right? Down on this one, we took the money, right? We took the money and divided it by $2.50. You know what? This one, we can probably improve it. We already have money in our expression. I might use T for total, and we divided that by $2.50. And what did that tell us? That didn't tell us the cost. That told us the number of rides that could be purchased on this particular bus.